Is that where we were? Yeah. Okay. So we talked about different threats to internal validity. All right. We have talked about these main ones: history, maturation, instrumentation, testing, regression to the mean, and attrition. I'd like you now to dig around in your notebook and see if you can find this handout. I gave it to you back when we talked about the 4 different types of validity that we will analyze in this class. We will use when we're looking at different studies. If you absolutely positively cannot find yours, you don't know where it is, anything like that, I did bring a few extra copies just in case as a backup.
Would you prefer us borrow an extra copy or look on with a neighbor?
I can give you one, that's fine, so you can write down things. If you can't find yours, I realize that I give lots and lots of handouts, so you might miss one. Can you pass that back for me, please? There's a new handout up here, too, if you didn't grab it on the way in. There's a new one for today. Okay, so the first thing where I want to start is to let you know that, and I mentioned this a few minutes ago, we are going to, did you find it? Yeah. Excellent. Okay. We are going to start preparing for our research design activity where we're having you guys play video games and gather data. We're going to start with the game Candy Crush. Or Candy Crush Saga. It doesn't mean that that's the only game we're going to play, but that's a really nice neutral baseline game that is free. These are the restrictions on the games we can play in the class. Has to be free, so no 99-cent games or $4.99 games. No super fancy games. Has to be free. It has to be available on the Android, the iOS, the Windows Phone platforms. Okay, so everybody has to be able to play it on their smartphone. So we have to have that restriction. It also has to be available for people who don't have smartphones, free on computer. Okay? So Candy Crush meets those requirements in that it's free and it is accessible to everyone because we're trying to design a learning activity where everyone has access to the resources at no cost. Okay? So if you have your phone with you today, and you have wireless or data available, and you can download Candy Crush if you don't already have it on your phone, please feel free to take a minute to log into your app store and start a download so you can have Candy Crush on your phone. Because if we can get a few people in the class who have it on their phone, then we'll be able to take a look at it later when we start talking about some design stuff, and you can come up with some ideas about variables that we're going to use. But you can go ahead and get that started while we talk about other stuff. All right, so we talked about those 6 main threats to internal validity. On this handout, there are many more. And in Chapter 11, which you read for today, there are many more threats to internal validity. What I wanted to do was give you an opportunity now to ask me any questions you might have about these other threats to internal validity, or if we need to talk about any of the ones we have already discussed in any more detail to make the differences clear to you. So please take a moment to take a look at your handout, look at the other things on the back side, see if there's anything on the handout where you think you don't understand that threat to internal validity, or you'd like me to explain it a little bit more. Yes?
Could you go over insensitive measures for me a little bit? I guess.
Okay, so it sounds like, are you looking at the one that says reasons for null results? We're not doing that one yet. We're talking about this one. Threats to internal validity. Reasons for null results, we're going to do it again. That's cool. I promise we'll talk about that. Absolutely. We're talking about threats to internal validity. So we did not, for example, in class talk in detail about history by selection, maturation by selection, instrumentation by selection.
Those are the things we're talking about in class today.
I'm giving you, if you find that the descriptions on the handout are not sufficiently clear, I'm glad to address those questions now. Okay. These are those particular, like the by selection ones, the ones that are 2 together, those are not covered in your book, and I just want to know if you need me to give you more information or if the handout is enough. Yeah.
When we're getting quizzed or tested on that stuff,
yes,
would it be incorrect to kind of lump all of the by selection things together?
What do you mean?
Like, 'cause there's all, I don't know.
Okay, let's take a look at those by selection ones and see kind of what's going on with them. Okay, let's see what it is about them that makes them. This is from the threats to internal validity handout that I gave earlier in the semester. Do you have it in your binder?
Yeah.
Okay, you want to pull that out because we're looking at it right now.
I guess I was thinking that they're all like selection effects.
They are types of selection effects, but here's what makes these unique. Okay, remember that a selection effect has to do with who gets selected for the study, that the selection process somehow results in the groups being unequal in ways that you don't manage. And because of those differences, your groups are no longer really similar enough to compare, right? You've put there's a difference in there that could be an alternative explanation to the variable you're actually trying to manipulate. The by selection threats, instrumentation by selection, maturation by selection, history by selection. These are threats to internal validity that affect one group in this study more than others. So for example, say that I'm trying to be a thoughtful researcher and I want to do a study that has samples from across the United States. Because I don't presume, for example, that students who are going to universities on the East Coast are necessarily exactly the same as students who are going to universities on the West Coast. They might be tapping into different populations. I want to gather data from the East Coast and the West Coast. Okay? And maybe even right there in the middle of the country in the Midwest. Okay? 3 kind of very different regions, could draw from different kinds of populations. So I'm gathering data across the country. Different labs, different schools. Now, I'm gathering data, and then at some point while we're gathering data in the study, a hurricane hits the East Coast. Okay? That hurricane, that history, that effect of history, is going to disproportionately affect the East Coast schools in my study. The Midwest schools aren't going to be affected. The West Coast schools aren't going to be affected. But those East Coast schools are going to be affected. And so the effect of history now isn't affecting all my groups the same. It's only affecting one subset, and that's the students who are enrolled in schools on the East Coast. So sometimes history effects, if you have people really far spread out, they experience history differently, especially if you're talking about a place like the United States. It could be tornadoes move across the Midwest, and my Midwest schools are affected. The coastal cities are fine, and my coastal schools are unaffected. Could be West Coast, Godzilla could come and take it off the map, and the Midwest and East Coast are fine. Anything could happen, right? But if one of my groups is affected by a historical event in a way that other groups are not, then I would say that I have an effective history by selection. Instrumentation by selection, maturation by selection, has to do with if I have groups that I expect to be maturing at different rates, or if the groups in my study are maturing at different rates with regard to whatever it is I'm looking at. If we're talking about, for example, studying behavior, and I happen to have students in my study who are freshmen, and I have students in my study who are seniors. I want you to think about, how did you study as a freshman? Study as a freshman. Remember what that was like? We were like, I don't have to read the book. I don't have to go to class. I don't have to take notes. I remember I used to be the coordinator for Intro Psych. And we would do a survey at the beginning of every semester, like they do on SONA. We would ask students what grade they thought they were going to get in the class. And I kid you not, one semester, all but 4 students, of all students enrolled in Psych 1101, all but 4, and we're talking more than 1,000 students, said they were going to get an A. 3 said they were going to get a B, and 1 said they were going to get a C. Out of about 1,200 students one semester. Because freshmen are confident, right? They are sure, they know how to study. They're like, I'm in college, I got this, I was a good student in high school, I had a good grade point average, I'm in college, I got this. What did you learn freshman year about studying in college and how it's different from that you have to?
Your mom's not there to tell you to study.
Mom's not there to tell you to study. In fact, the professor may just be like, it's in the syllabus. They won't even say that there's a homework assignment. They'll just assume you're reading the syllabus because they gave it to you, right? And you're just like, oh, you mean I actually have to pay attention to that thing? I actually have to read it? And so think about how freshmen study and how freshmen prepare how is that different from what you do now? Is it different at all? It's not, you're like, no, I'm just the same. I'm still that way. Well, so we could have some variability, but do you think that freshmen and seniors are likely in general to study differently? Yeah. So if we're looking at them over time and how their studying behavior changes, freshmen are more likely to change a greater amount automatically in their studying behavior because they're so extreme in terms of not studying when they get here than seniors. Seniors might change over the course of a year too, but probably not as much because they have less maturation to do. They've already gone through some of the steps. So we could think of this as a maturation by selection. One group is just naturally going to be maturing at a different rate with regard to what we're looking at because of what they've already been through. Instrumentation by selection has to do with the way data are recorded. And you can imagine, we talked before about how an instrument, like a computer or a video camera or a tape recorder or anything like that, can wear out over time and become less accurate in the way that it does measurement. Well, imagine that if you are doing one of those studies on two different coasts, or even just studies across town from each other. Maybe one lab has more resources than another, one lab has a little bit nicer equipment than another. It depends. Maybe one lab's stuff breaks down at a faster rate than another, and as a result, the data gathered in one lab are less accurate than data gathered in a second lab. That's an instrumentation by selection effect, and it could potentially result in the researchers observing a significant difference between the data gathered in the two labs. It doesn't have anything to do with their manipulation. It has to do with the quality of their equipment. So you want to keep in mind these kind of combined effects when you have a threat to internal validity that affects one group in the study quite differently than it affects the others. We would call that the threat by selection, where it's going to artificially create differences between the groups that are about some threat issue, not about the actual manipulation. Does anybody have any other questions about those things or anything else on that handout before we move on to something else? Are we good? Okay. Now, threats to internal validity are typically things that we're worried about because they can result in type 1 error. Right? Type 1 error is when you observe differences in your data that aren't really there in the real world. Right? So you get a false positive, effectively. Type 2 errors are what? You get a false negative. Right? You miss an effect that's really there in the real world. So we translate that into statistical terms, it means you retain the null hypothesis when you should have rejected it. Right? So what I want to talk about now are reasons that we might get null results, that's today's new handout, that we can actually try to do something about, trying to minimize the likelihood that we will commit a type 2 error.
I was working on the worksheet. Am I behind or something?
No, you're not. The worksheets, I made a mistake. I was thinking it was due today. It's actually due next time. If you already got it done, no, wait. If you already got it done, you can make changes and resubmit. No penalty, no nothing. You're good. You're good. You're good. No. Yeah, you're good. You're good. Okay. So let me switch over to this, to DocCamp. So now we're going to talk about type things that contribute to type 2 error. So one thing that can contribute to type 2 error is having a weak manipulation. Okay, now what do we manipulate? Independent variables or dependent variables? Independent variables. Right? So weak manipulation has to do with how we have designed our independent variable. And when we have a weak manipulation, what it means is that we have designed the variable in such a way that the levels really aren't that different from each other. And so the contrast between level 1, level 2, and level 3, for example, of that independent variable is really small. It's a weak manipulation. We haven't really clearly created different groups or different experiences for the subjects to have. The example that I have on your handout is, imagine that you're doing research with chimpanzees and you want to reward them for learning how to do a particular task. And your hypothesis is that the bigger the reward, the faster they will learn, because they'll be more motivated to try and get more of the reward because it's big, and they like big rewards. So you decide to create 3 reward conditions. 1 raisin, 2 raisins, 3 raisins. Okay, now, it is totally true that chimpanzees love raisins. They are all about the raisins. They also love M&Ms, just so you know. But you have to be really careful, because if you let them get a hold of a bag of M&Ms, they will totally just slam the entire bag. They get fat, they will sit there and just eat. They love M&Ms a lot. They also love raisins. But I want you to think about a chimp. How big is a chimp? They're big, right? These are big creatures. How big is a raisin? It's little. So I want you to imagine if you are a big old chimp and someone's giving you a 1 raisin versus 2 raisins versus 3 raisins. Now, it is true, technically speaking, that the 3 raisins is 3 times as much reward as the 1 raisin. That's true, but does the chimp really notice a difference between 1 raisin, 2 raisins, or 3 raisins? Think of those big old chimp mouths and a little tiny bit of dried fruit. Do you really think this much dried fruit versus this much dried fruit versus this much dried fruit is going to make a huge difference in how fast that chimp decides to learn? Maybe. Maybe they're like, woo, this much dried fruit. Yeah, I'm going to work a lot harder for this much dried fruit. Yeah, maybe. But it's probably more likely that it's not going to be a big enough distinction that they're going to be like, yeah, I'm totally going to work harder for all that extra fruit. Because they're like, it's just a tiny little taste of fruit nibbliness in my mouth, and I can't even really tell the difference. Okay. So that would be a weak manipulation. Yes, you've created 3 different groups, but they're not really different enough. You have to really switch it up a little bit more. Like have one where they get some, like a snack they kind of like cucumber. And then another one they get grapes, which are even better. And then in the El Primo condition, M&Ms. And so you have to really make some kind of clear distinction where they're, this is something you could tell. Now, how could you figure out if they really think 3 different treats are different? Well, you could do what we call manipulation check. And that's where you go in and gather data on another measure just to make sure that your manipulation is really doing what you think it's going to do. So if you did a study, a little kind of test ahead of time, and you gave chimpanzees the option of selecting, you had a little cup with 1 raisin, a little cup with 2 raisins, a little cup with 3 raisins, and you randomly ordered them in front of different chimps and look to see what they take. And it's kind of just a crapshoot, right? Like they're just arbitrarily picking whichever one is closest to their hand. Well, that would tell you they don't really notice a difference between 1 raisin, 2 raisins, and 3 raisins. It's not clearly a preferred, 3 raisins isn't clearly better to them than 1 raisin. So you could do a manipulation check like that to make sure that the way you're creating your different groups is really creating different groups in a meaningful way rather than just some kind of arbitrary way that isn't going to result in any kind of meaningful difference in behavior. Then, did you guys talk about ceiling effects and floor effects in 3510?
They were mentioned, or at least in my class they were mentioned, but they weren't in the actual material. You just talked about
You just
them.
kind of touched it.
Yeah.
Okay, so where's the ceiling?
Up front.
Where's the floor?
Down
Down there. Okay, so ceiling and floor effects have to do with performance kind of maxing out and getting flat because subjects can't score any higher, or subjects' performance being really low because they can't do any worse. So imagine if you were gathering, say you're gathering data, you've done this weak manipulation where you're having people do a hard problem, a harder problem, or an even harder problem, right? You're having them solve problems, but they're all, even though there's some differences between them, they're all so hard that everybody's performance on the task is bad. Okay? then what you're likely going to get is a floor effect. All the scores are going to be really low, and you're not going to be able to see any difference because your weak manipulation of a hard problem, a harder problem, and an even harder problem was still within a range of problems so hard that most people can't do them. So yeah, they're different, but they're still all so hard we can't do well. Similarly, you could do a weak manipulation where you had super easy problem, super, super easy problem, a super duper easy problem, right? And in that case, you might get, I mean, you've created 3 different conditions with 3 different problems, but you might get a ceiling effect where everybody can do all the problems comparably well and they're all doing them all super fast or super accurately. So your weak manipulation, again, did not create meaningfully different groups, and they also resulted in ceiling effects because everybody could do all the tasks comparably well, and it just leveled out at max performance. Everybody just rocked everything. Super boring, not interesting at all to get that kind of result. Now, we can flip over. Weak manipulation is about independent variables. Insensitive measures, all for you, are about dependent variables because we measure dependent variables, right? So if we have a measure that is not sensitive enough for what we're interested in, then we might miss differences that are actually there. Imagine, for example, if I'm trying to weigh adults versus weighing babies. Now when I weigh adults, if I want to observe differences in adults' weight, I'm probably going to use pounds. Right? That's totally normal. We all weigh ourselves in pounds, or maybe even kilograms, right? Or if you're fancy and British, stone. Right? But we use fairly large measures. Okay? We don't use things like grams. I'll be honest with you, I do not want to know how many grams I weigh. That's going to be a really big number, and I don't want to know what it is. The pounds number and the kilograms number is enough. I don't need to see the grams. But if we're talking about babies, it wouldn't really make sense to weigh them in pounds, right? Because what's the range? Maybe, for a viable baby, maybe 3 or 4 pounds up to maybe 10 pounds, right? But most babies are kind of in the 5 to 7 pound range, although there are some crazy giant outlier babies. Huh? Are you a crazy giant outlier baby? What did you put your mother through? How big were you when you were born?
I think I was like 7.5.
7.5? That's not bad.
I was 10.
You were 10?
Yeah.
Oh my god.
Yeah,
Oh,
like 10,
yeah.
like 10.1, or like I was like 10 and some change.
Oh my gosh.
Yeah.
Man, my daughter was only like 6.5 pounds, and that was plenty. All right, but the point is that we're not going to measure babies using pounds because that's not going to show us meaningful differences across babies. We need to have a measure that's appropriately precise for the group or the thing that we're looking at. So for babies, we're going to go down to ounces or grams because that's where we're going to have a measure that's sensitive to the kinds of differences that are present in the population we're looking at. It wouldn't make sense to use ounces or grams to measure full-grown adults because that's not really how we vary. We vary on a bigger scale. We can use a coarser scale. If you're measuring, like if I'm measuring how fast it takes someone to recognize or to make a decision about whether this is a word compared to whether this is a word, okay? Turns out that there is a delay. When people see the first one, they respond very quickly because that is a real word and they're pretty fast. They can usually do it in between 250 and 350 milliseconds. But if I show them this word, what do you think happens? Because if they just read it out loud, what happens if they read it in their head? Toad. It sounds like a real word, but if they look at the spelling, it's not a real word. So what happens is they go toad, and then they go wait. And then they have to check the spelling. and then they hit no, right? And so it actually takes them a little bit longer, but it really only takes them about 100 to maybe 200 milliseconds longer to figure out that TODE is not a word. Now, if I'm measuring people's response time in seconds, I would see no difference between those two. They would both register as not 1 second. So I would get nothing. It would show that they were both comparably fast, and that's not what actually is going on. If we look at milliseconds, we see quite clearly that there's a significant difference between people's ability to judge that TOAD is a word and how fast they do that, and whether TODE is not a word. We get a significant difference, but it's because we have to go down to the millisecond level. If we were using seconds, that would be an insensitive measure. It's not precise enough for the kinds of differences we're going to see. So you want to make sure that your measures are appropriately sensitive or appropriately precise. The units are small enough, but not too small. Right? I don't want to measure babies in milligrams either. Grams is great. I certainly don't want to measure adults in milligrams. I really don't want to know how many milligrams. So those are two. So if we're thinking about problems with independent variables, think about weak manipulation. Thinking about problems with dependent variables, think about precision and how sensitive the measure is. Now, other things we want to think about have to do with how, if we have maybe too much variability, or things that might add variability to our measures. And they can make it harder for us to see differences between groups because they make them more similar in that they make everything look really variable, and so we can't tell the difference. First one of these is measurement error. Did you guys talk about margin of error or measurement error, sampling error in 3510? That's what we're talking about here. Okay? So measurement error is always there. Okay? We cannot, will not, and I mean we can do our best, but it's always there. Every time we take a measure from a subject, there will always be some tiny bit of error. And we just want to minimize it as much as we can, try and get the purest value that we can. But every time I gather data from a subject, I've got the person's or the subject's actual score plus some amount of measurement error. So every data point has a little tiny bit of error. We want to make it as small as possible. And we can do that by increasing the reliability of our measure, by making sure that our measures are appropriately precise, by increasing the sample size. Measurement error, one example that I really like to use for measurement error is political polls. And I know it seems crazy that we would actually be getting into political polling, but it's already happening, right? And we're already seeing things about how likely it is that Trump's going to get the Republican nomination. Huh?
Oh, God.
Okay, that Trump might get the Republican nomination. Yes, that's going to be preserved on YouTube for all time. I'm so proud of that. Or whether Bernie Sanders or Hillary Clinton will get the Democratic nomination. Okay, that's kind of the two people who are front running right now. Now you're going to go Bernie?
Oh, I've been Bernie.
You've been Bernie? Okay. Who knows what's going to happen at this point? It's all kind of crazy. But if you see on political polls, they'll often say, so people, these two candidates, this percentage of people say they would vote for this candidate, this percentage of people say they would vote for this candidate, with a margin of error of plus or minus 5%. And what that means is that each one of those bars could be 5% higher or 5% lower. And that's how much error is in it. So they're saying we think that the actual real measure is somewhere in this 10% window, because we know that there's some error in our sample. Because to the extent that the sample is not identical to the population, you're going to have error. The only way to eliminate sampling error is to have every single person in the sample, or every single person in the population be in the sample, and that almost never happens. And even if you do that, somebody can be tired, somebody can be hungry, somebody can be in a bad mood, whatever, and that can contribute to how they respond at that particular moment in time, introducing error. So even if you manage to get every single person from the population into your sample, they still might respond differently on a given day and time under different circumstances and introduce some error into your study. So we can't totally get rid of it, but we can try to minimize it by getting large samples and trying to make sure that our measures are very clear and precise. Another thing that is always there that we can't totally eliminate, but we can manage, are individual differences. Now, individual differences are particularly a problem for between subject studies because those are the studies where we have totally different groups of people in each condition. And so we're worried that the ways that the people in group 1 are different from everybody in the world might be different than the ways the people in group 2 are different from everybody in the world, might be different than the ways the people in group 3 are different from everybody in the world. And we have to be so thoughtful because the number one challenge of creating an effective between subjects design is creating groups that are similar enough to compare. And since individual differences exist, since we don't have clones that we can put in all of our conditions, we have to deal with them. And even if we had clones, I mean, we know from having studies that have been done on identical twins and identical triplets and identical quadruplets raised by the same parents, going to the same schools, living in the same towns, they still grow up to be different people. Right? So even if all your biology is basically the same and all of the environment stuff is basically the same, you still turn out different because everybody has you could be different. It's just a different circumstance, different day, turn it down a different street, and your life totally changes, right? So individual differences can be managed by using things like random assignment to try and distribute them evenly across conditions. We can also opt to try and do studies in a within subjects design, so that every group, so there's really only one group, and the subjects in every condition are the same people, so whatever their individual differences are, they're the same when they experience condition 1, and they're the same when they experience condition 2, and the same when they experience condition 3, but we're just, we're holding the individual differences constant as much as possible across the condition. So that's one possible way to deal with it. Again, if we can't do our study as a within subjects design, then we are best off increasing our sample size. Again, the bigger we can make our sample, the more likely we are to have people in our sample who represent the full range, or as close as possible to the full range of individual differences that exist in the population. And then when we do random assignment and put them into conditions, we have the best chance of getting a nice, even distribution of those differences across conditions. Okay, so sample size is always good. Increasing it is generally never a bad plan. Lastly, there's situation noise. The environment in which we conduct our studies can add noise to our data. An example I gave in my last class was we were doing a study where people had to read these sentences, and some of the subjects were getting run by this one research assistant. And this was a guy who liked cologne. I don't mean cologne, I mean cologne. You've ever met people like this? Cologne or perfume, something. It's like they just bathed in it or something, like they walk by and 10 feet away, you're like, I can't breathe, right? Because for some reason, they just feel like they need to be powerfully present. That the scent is, maybe they just don't smell very well, so they don't realize how really strong the smell is, but also some people are just really sensitive to those smells. Like I know I've had students who are like, I can't even walk through like the perfume area in a department store because all the different smells are so overwhelming, it makes me sick. Well, anyway, some people in our lab were run with Mr. Cologne, right? He was the guy who would run them. And then other people would run other subjects. And we had some students later comment that they found his cologne really overpowering and it was distracting while they were trying to perform the task because they kept trying, like he's sitting there in the lab with them and they're just like going, I kept trying to concentrate on the task and I just kept thinking, God, this guy's cologne is really strong. So that's an example of situation noise. noise, right? Anything in the environment that might distract subjects from the task you want them to do. And it might affect people differently. I mean, there could have been subjects who were like, I love that cologne. Like, they performed even better because they're just like, oh, that cologne, it's so hot, and I just love it. I'll be in a room with this guy forever because it's so great. Right? Who knows? But if there's something in the situation that's in the environment that's adding variability to the subject's experience, that can add sufficient noise to your data that you might miss differences that are otherwise there. What we're focusing on here when it comes to these null effects, well, in general, when we talk about trying to make sure we get that we observe effects that are really there and we don't find effects that aren't there. We're talking about making sure we have the right amount of statistical power. Statistical power is basically our ability to correctly observe differences and correctly observe non-differences. And our power of our statistic. A very powerful statistic will be able to observe very small differences, even if they're hard to see. And one way that we can increase power is through sample size. So if you have really small effects, like you're expecting relatively small differences between your conditions, but you think that they're actually real differences, one way to make sure you see them is to have a very large sample. Do you guys know how the relationship between sample size and effect size and significance? Did you guys ever talk about that in 3510?
Yeah.
So the idea is that, so if you have a treatment effect, that's basically how big of an effect the independent variable has on the dependent variable. How much change does it cause? Now, it might cause a little bit of change, it might cause a lot of change. If the independent variable causes a lot of change in the dependent variable, that's going to be pretty easy to see. That's a large treatment effect. Okay? The manipulation you did really, really matters in terms of how subjects respond to that dependent variable. If it causes a really small change, then you might not notice it. Depends on how sensitive your measures are, depends on how big your sample is. You might miss a difference that's kind of small, because small differences are harder to catch. The example I typically give, you can think about treatment effects kind of like this. Imagine that you're standing there on a beach. You're in Tokyo on a beach, and it's kind of dusk, a little bit hard to see, not super bright outside. What do you think the chances are, if you're just standing there on the beach looking around, that if there is a cat on the beach, you're going to notice it? One cat on the whole beach. Maybe.
Are there other people on the beach?
Sure.
Okay, then probably not.
Probably not. There's other people on the beach, especially good-looking people on the beach, right? Then you might not notice that cat on the beach. Okay. What about if there's a cow on the beach? You think your odds of seeing the cow are a little bit better than seeing the cat?
Yes.
Yeah. Even if there's just one. Now you might still miss it because there's only one and it's a big beach. But chances are, if there's a cow on the beach, you're going to notice it. Okay, if you're standing there on the beach in Tokyo and Godzilla rises up out of the ocean, what do you think the chances are that you're going to see Godzilla? Really, really good.
Yeah.
Right? Super, super good. So think about the cat as a small treatment effect, and think about a cow as a medium-sized treatment effect, and think about Godzilla as a large treatment effect. Even if there's only one data point, Godzilla, you're not going to miss him because the effect is so big. The difference between Godzilla being there and Godzilla not being there is so big, you can't miss the fact that Godzilla has arrived on the beach. Cow, better chance, but possibly you could be distracted and miss the cow. Right? Your chances might be a little bit better if there were 5 cows on the beach or 10 cows on the beach. Right? Get a little kind of mini herd going, and chances are you're not going to miss the cows on the beach, even though they're kind of moderately sized, because once you got 10 cows together, it's kind of hard to miss. Now cat. Okay. One cat on a big old beach with people on the beach and stuff, probably not going to see it. Even 5 cats on the beach, maybe 10 cats on the beach you wouldn't see. But what about 1,000 cats?
You won't know.
You are not going to miss a herd of 1,000 cats working their way down that beach. They're like, this is the best litter box ever. Right? I got food on one side, there's fish guts and all kinds of good stuff, and then it's just a litter box right here. This is our dream home. We are hanging out here forever, 1,000 cats in a giant herd. Now, think about it this way. So that little tiny treatment effect, you're not going to miss it if you have enough data points, right? 1,000 cats, 1,000 chances to see the cat, you're not going to miss. 1,000 chances to see the cat, basically. Whereas with a medium-sized effect, you might only need 10 chances to see the cow. With Godzilla, even 1, you're not going to miss it. So there's a relationship between how big the treatment effect is. Do you have a cat or a cow or Godzilla? And how many chances you have to see it. 1, 10, 1,000. And the statistical power you have is related to those things. So when you have a really large treatment effect, you don't need to have a super powerful statistic to get a significant result. Because it's going to sense the difference between Godzilla there, Godzilla not there, really easily. As the treatment effect gets smaller, you need more power to be confident you're going to see the effect. So how do you increase your power? Increase the number of cows or increase the number of cats. You have to increase the number of opportunities you have to see the difference in order to make it work. So you need a very powerful statistic to see little tiny effects. Basically, you need a super better, super refined tool to see small effects, but a bigger tool will be able to sense large effects relatively easily. And we're always trying to make sure that we're managing, that we have an appropriate amount of statistical power. In fact, there are calculations you can do. We won't do them in here, but it's very common to do these in research labs where they'll actually do the math to figure out, okay, given the size of treatment effect I expect from the literature, how many data points do I have to gather? How many subjects do I have to run in order to be confident that I've got enough statistical power for this kind of effect? And so we can do math to figure that out. And that's what we're trying to be thoughtful of is, you know, how big do I think the effect is going to be? And then how big do I need my sample to be so that I can feel confident that I'm getting a correct result and not committing a type 2 error by missing something that my measures are just not sensitive enough to find, or I don't have enough statistical power to find, or my manipulation is too weak to find. Does anybody have any questions about these things? Does that make sense? We're good? Okay. So, my next question to you is, how many of you have Candy Crush on your phone now? Okay. Open it up. Oh, you know, I went to DragonCon this weekend. It was super awesome. It was great. And people have been asking me what the best thing about DragonCon was. And of course, the mom in me says the best thing was when my daughter and her boyfriend won Best Anime Costume.
Nice.
Sweet! In the Holloway Costume Contest, which is popular vote, which is people who attend DragonCon went and voted which one they thought was the best, and they picked her, obviously. That's right. But, so that was pretty sweet, the mom, but the teacher in me was super most excited about the fact that I met Big Bird.
Oh.
I met the guy who did Big Bird and Oscar the Grouch for 45 years, and he gave me an autographed picture, and in the picture he said, "Thank you for being a teacher, love Big Bird." I know. And he's like, I would say that I was probably your first teacher, and I think that's probably true. He says, "Thank you for continuing my work." I'm like, I'm blessed by Big Bird. That's so cool. Of course, I'm also blessed by Oscar the Grouch, but he didn't get it. So, but yeah, I got to meet Big Bird this weekend. That was cool.
Did you get any posters?
Did I get what?
Any posters?
Any posters?
I went Monday when posters half off. I still spent $500.
There's just some good stuff you can get there. Yeah, on Monday when everybody's trying to get rid of all their stuff. Yeah.
I got a silk tapestry.
You did? Sweet.
Cool.
Yeah, gotta hit the dealer room. It's great. Okay, so everybody's got Candy Crush up on their phone, or people who have it. Are you sitting maybe next to somebody who has it on their phone? Okay. So, oh, we're turning it on. Oh yes. Okay, that's going to get really annoying if we're all doing that. So we might want to have the sound off for now. But, yeah, shut up. Okay. So we're going to skip the intro. Now, look at the screen. You have it in front of you. Look at the screen. Okay. What kinds of numbers do you see on the screen, just to start off with? What kinds of numbers do we see?
Small ones, like
Small numbers,
yeah.
yes, they're small numbers. I can't get the good glare up here, but it looks like on the top we have a target number, right? That's the score you have to get to beat this level, I think. Is that right? Who in here plays Candy Crush? Somebody's got to know. If not, we'll just figure it out. Okay, and then down at the bottom, we've got scores like the number of moves, and we've also got an actual point score. Do you see that on your screen? Okay, so these are just basic numbers. These are things that could be potential dependent variables or something we might be able to use in our studies, right? If we're going to design experiments where we're gathering data using Candy Crush, we might measure how many moves it takes someone to finish a level, right? We could measure what their score is once they finish a level. Okay, so that's another thing we could measure. We could look at a combination of those two things, right? We could come up with something where we look at, like, we want to categorize people by the, give them some score, like maybe multiply or divide their score by the number of moves and see like who has the most points for the fewest moves, right? We could do something like that. Candy Crush is set up so that it occurs in episodes. Because we're all going to be very pleasant, right? Relaxing. You'll probably be really sick of it by the time the semester's over. All right, so it happens in episodes, and each episode has a certain number of levels. So for episode 1 and episode 2, each one has 10 levels. So it's also possible that we could take scores for people by episode, right? What's their high score after they've completed the first episode? Or how many moves did it take them to complete the episode? We could also do something, if we wanted to get a little crazy, we could expand on what's actually available here in the game, and we could time. We could say, all right, everybody start level 1. We're going to time to see how fast it takes you to get through level 1, or how fast you can get through levels 1 through 5, and see what people's duration is for actually getting through the first 5 levels. These are all different things we could measure from this game. And we're restricted in what we can measure based on the kinds of data that are generated by the game itself. If you're thinking about, and I want you to be thinking about this, if there are other games you think we could use in class that would be appropriate, that meet our requirements of being available across platforms and being free and being relatively neutral in content, so we can't have like Baby Hunter 2000, right, or something like that. Can't do that. But something that would be relatively accessible to most people. You want to be thinking about games like this. Okay, we're going to start with Candy Crush, but if you guys have suggestions for other games you think would work, start looking through, talking to your friends, look at the games that you like to play. If you don't ever play any games, ask people who do play games. See if anybody has any ideas of other games we could play, because the sooner somebody makes a better recommendation than Candy Crush, the sooner we might be able to pick a different game. Okay? But if you're totally good with Candy Crush, we're going to start with that anyway. All right, so now my question to you is this. Given that we have those kinds of dependent variables that we could work with, let's think about now what kinds of independent variables we might use. Okay, so I'm going to write stuff down. I want you to think for a minute about what independent variables we might test. And you should be able to tell me whether your independent variable is between subjects or within subjects, or if it could be either one. And you want to be able to tell me if it's a manipulated variable or a subject variable. So what I want to do first is I want you to find somebody else in the room if you like to work in a group, or if you like to work by yourself, you can work by yourself. And I want you to brainstorm for 5 minutes all of the independent variables you can think of. Remember, we're going to be gathering data in Psych 3530 only. Okay, so independent variables you think we could use to compare create experiments with the dependent variables we just discussed. Go ahead.